NASA keeps photographing something moving on Mars. Dark streaks appear on crater walls, grow over time, then disappear again. Some stretch hundreds of meters across the surface. They return during warmer seasons, fade when temperatures drop, then come back again the next year. That should not happen on a planet this cold and dry. Mars should not feel active. Because Mars is not Earth, its atmosphere is so thin that the pressure is less than 1% of ours. Temperatures can fall below -100 degrees Celsius. Liquid water should rapidly evaporate or freeze. And yet, NASA orbiters kept photographing behavior that looked active. Not once, repeatedly. The images came primarily from the Mars Reconnaissance Orbiter, a spacecraft launched in 2005, HiRISE, a camera capable of resolving objects roughly the size of a desk from orbit. And when scientists used it to repeatedly photograph steep Martian slopes, they noticed something deeply unusual. Dark lines, thin at first, then longer, then darker, as if something had flowed downhill. The features became known as recurring slope lineae, RSLs. And the reason they triggered so much attention was not just how they looked. It was when they appeared, because many of them emerged during warmer Martian seasons, expanded over time, then faded again when temperatures dropped. That pattern resembled a cycle, almost like a process, and processes require mechanisms, which immediately created a problem. Mars was supposed to be mostly inactive, a cold desert world, a planet that lost most of its atmosphere billions of years ago. But these slopes behaved dynamically, and the deeper scientists investigated, the stranger the situation became. At first, one explanation dominated the conversation. Briny water. Not oceans, not rivers. Tiny amounts of extremely salty liquid, briefly becoming stable on the surface during warmer periods. It sounded almost impossible, but Mars forces scientists to think in extremes. Because salt changes physics. On Earth, adding salt lowers the freezing point of water. That is why roads are salted in winter. Some researchers proposed that Martian salts, combined with seasonal heating, might allow microscopic flows of liquid brine to temporarily exist. And if that were true, the implications would be enormous. Because liquid water changes the meaning of Mars. Suddenly, Mars is no longer just a dead world. It becomes a planet where active chemistry still exists on the surface, possibly even environments where microbial life could survive. The excitement became so intense that some scientists argued these regions should be protected from contamination. Because if terrestrial microbes accidentally reached these slopes, we might never know whether future discoveries came from Mars or from us. But then, the conflict deepened. New observations began challenging the liquid water interpretation. Researchers studying temperature data, mineral signatures, and slope behavior noticed inconsistencies. Some RSLs appeared in places where liquid water still seemed highly unstable. Others behaved more like dry, granular flows. Instead of wet streaks, they may have been avalanches of fine dust and sand. Tiny particles destabilized by heat, just dry movement. And this is where the Mars mystery becomes far more interesting than most people realize. The real tension is this. Why is Mars still behaving dynamically at all? Because even dry movement raises larger questions. Mars should not feel active. That is the uncomfortable pattern hidden beneath years of orbital photography. Because the more images NASA collected, the more Mars stopped resembling a perfectly frozen world. Yet orbiters repeatedly photograph changing surfaces, dust devils crossing plains, fresh impact craters appearing, seasonal carbon dioxide ice activity near the poles, slope collapses, shifting dunes. Again and again, Mars behaves less like a frozen fossil and more like a planet still responding to forces. In some regions, dust devils carve fresh tracks across the surface that were not there weeks earlier. Near the polar regions, frozen carbon dioxide ice appears to crack and erupt seasonally. throwing dark material outward across the terrain. Entire dune fields slowly shift shape over time. These are not signs of civilization, but they are signs of activity, because a completely dead world feels static in the imagination. Mars does not always behave that way, not alive, but not fully silent either, because human beings tend to think of planets in absolutes. Earth is alive, Mars is dead. But reality is rarely that clean. A planet can lose oceans, lose atmosphere, lose magnetic protection, and still remain active in subtle ways. And Mars constantly reminds us of that, especially when viewed through the eyes of orbiting spacecraft. Some of the most unsettling high-rise images resemble veins spreading down cliffs. Others look almost biological from a distance. Dark branching patterns crawling across crater walls, because the human brain instinctively searches for familiar behavior. Movement, cycles. It exposes something deeper about how we interpret worlds beyond Earth. We expect dead planets to remain unchanged, still, frozen, predictable. But Mars keeps violating that expectation, quietly, through subtle recurring changes that force scientists to keep revisiting old assumptions. Even today, there is no single explanation that fully resolves every observed slope phenomenon. Some researchers strongly favor dry dust movement. Others argue that certain observations remain difficult to explain without at least transient moisture, because uncertainty is where science becomes real, not when every answer is settled, but when reality refuses to perfectly fit our models. And Mars has a long history of doing exactly that. For more than a century, human beings have projected expectations onto the red planet. Canals, civilizations, oceans, ruins, life. But each generation still encounters something new that reopens the tension. Not because Mars keeps proving fantasies true, but because Mars repeatedly reminds us that worlds are more complicated than our categories. Even the lighting conditions mattered. Scientists had to compare images taken months apart under nearly identical conditions to confirm that the changes were real and not simply shadows shifting across the terrain. That process took years, not because NASA lacked images, but because Mars kept producing patterns that resisted simple explanations. And perhaps that is the real significance of these images. Not that NASA photographed aliens, not that life has been discovered, but that a planet we mentally classified as dead still behaves like a world with unfinished processes. Something on Mars keeps changing, and the deeper we look, the less absolute our definition of a dead planet begins to feel.